problem number 2 is called as longest palindromic subsequence. So you are given a single string. Let's call that string as S. And now let me give you an example. AX, BC, X, XY, CA. Okay, so this is the string. Let's say that you're given. This is the string that is given to you. And the problem statement is find out the length of longest subsequence, which is palindromic, right? So I'll give you a couple of minutes, try to attack it. Again, this is also kind of classical, famous problem. So possible some of you might have done this. For some of you, it is going to be new. So again, try to attack this and try to find out how is this. Again, you already have a hint that it is going to be related to computing LCS. You don't even need to think about BP. Just think about the problem statement, right? You need to find length of longest subsequence that is palindromic. What does palindromic means? That reading a string from left to right and right to left, if it is exactly same, then that is a palindrome. Again, can you tell me the answer for this particular sample? What is the answer for this particular sample? Okay. So Oppo has got it, I think, perfectly correct. Yes. Ankit has also got it right. I think perfect. Dolly has also got it perfectly right. Awesome. So one of the subsequence, for example, could be, let's say, AXA. So this is a subsequence and this is palindromic because if you read AXA from left to right or right to left, it is going to be exactly same. But of course, we can do better than this. How about this subsequence AX and then let's say, okay, B and then X and then A. Okay, perfect. Yes. So AXBXA. So this is a subsequence of length 5. And I think this is the one of the possible answers, but you cannot find another subsequence that is palindromic and greater than length of 5. So answer for this is going to be 5. Yes, Sunanya, there can be multiple longest palindromic subsequence. Like Sukanya is saying, how about AXCXA? So this is also perfectly fine. AXCXA, this is also perfectly fine. But the length of this string is also 5. So how do we solve this? So you don't even need to think about DP if you know about LCS and if you can focus on the definition of how palindrome is actually defined. All right. So yes, a lot of people have got it right. Again, this is a little bit classic and famous problem, but again, it is good for practicing. How do you solve this? By using again LCS. So I'll drop you the solution and let us see how many people are able to understand all by themselves. So I'm going to declare another string S2, which is nothing but reverse of string S. Okay, I'm reversing the string S and now I'm calling that new string as S2. And now my claim is longest palindromic subsequence of string S is equal to longest common subsequence between S and S2. This is the claim of the solution that this is right. I'll give you a couple of minutes, try to understand what I've written, try to figure out whether it is right or not. And if you are able to understand that, hey, this looks like correct, then again, vote out yes. I'll give you a couple of minutes. Yes, Gopinath. Yes, Rutvik. This is awesome if this is true. But why is it true? I want you to reason it out by all yourself. And then, of course, I'm going to be explaining you why is this true. All right. So almost 90 people have already understood this all by themselves, which is awesome. Okay. Few people feel that this is not true. Okay. Perfect. Okay, so let's try to see whether this is actually true or this is actually correct or not. So first of all, let us try to take a sample. The string that is given to us is AXBCXYCA. This is S, okay? Now let us find out the S2 string by reversing it. So what is the reversed order of it? AC, YXC, BXA. This is what I'm going to get after reversing. Now, can you try to find out a longest common subsequence between S and S2? Looks like A is common to both of them. Awesome. X is common to both of them. Awesome. Let's say B is common to both of them. Awesome. X is common and again A is common. So as you can see, string AX, BXA is common subsequence to both of them. So, and this is the longest possible common subsequence. So yes, this is like literally, it works for this particular sample and answer is 5. So finding LCS of S and S2 is actually giving us the longest palindromic subsequence for string S. We can verify it in this example. Now let us try to understand the intuition behind it, and that goes in the definition of the word palindrome itself. How is palindrome defined? Palindrome is defined as if you're reading the word from left to right and from right to left, they should spell out exactly the same. If I'm reading this word from left to right, it is going to spell like AXBXA. If I'm spelling it from right to left, it is going to spell like AXBXA. Both of them are exactly the same, correct? So this is the definition of palindrome. What is S2? S2 is nothing but we are reversing the string S. What do we mean by reversing the string X? It basically means now that the string S2 is going to be same as if I'm going to be reading it from right to left. If I read string S from right to left, that is exactly what string S2 is all about, right? So S2 is all about reading the string from right to left, and S is us reading the string from left to right. Now, if we take longest common sequence between both of them, then this common subsequence is definitely going to be palindromic. Why? Because the very definition of palindrome is that if you read a string from left to right or right to left, it is going to be exactly the same. And if we try to find the common subsequence between S and S2, this is going to be exactly the same, that same as reading it from left to right is exactly the same. So every single longest common subsequence between S and the reversal of S is going to be palindromic. And because LCS is going to find length of longest such possible common subsequence, so LCS of S and reversal of S is actually going to be giving us the longest palindromic subsequence. So let me quickly take another poll and let's see now how many people are able to understand this, right? Very simple application. We twisted one little thing, but we are still able to solve it using the same concept that you have understood. All right. Yes, Surya, that is also perfectly correct. I'm going to also going to be talking about that as well. All right. So this is awesome. Perfect. And okay. So almost 98% people have understood this, which is great, which is awesome.